Welcome to Variations 4, Lights and pH unit. In this video, we're going to cover question number 30, where we talk about hydrogen, potassium in times of acidosis and alkalosis. So map 13 draws out a very nice chronological kind of concept map thing, events chart that we've been looking at throughout the whole study here, this format, and you feel free to read through that. I'm going to say exactly what's in this chart using a picture form because I think for this concept it's a bit easier. So let's go and talk about the acidosis first. Okay, so let's assume the body is in acidosis, and it doesn't matter in this case if it's respiratory, metabolic, or both in terms of origin. It's in a state of acidosis. We established earlier on that in times of acidosis, there are increased hydrogen ions in the bloodstream. They are the acidic side of things. So in acidosis, we've established that there'll be more hydrogen in the blood. Now, a principle of physics that we haven't talked about yet is how solutes flow. We've talked about how fluid flows and how fluid likes to flow to where there are more solutes. But now we need to talk about how solutes, what are their properties? Solutes like to flow from areas of high concentration to low concentration. If they're able to do that, they will. So in a case where you have lots of hydrogen outside in the extracellular fluid, it's going to want to flow to areas where there are less of itself, lower concentrations of itself. So it will naturally start to flow into the intracellular fluid. There's nothing the body can do to stop that kind of osmotic flow of lights and ions. They just flow naturally. The only thing that the body is able to control is sodium and potassium by way of the sodium and potassium pump, as you know. So here you have a case of hydrogen that's in excess because we have acidosis, flowing into the cell to try and move from areas of higher concentration to areas of lower concentration until the H is equal in concentration on both sides, if that's ever possible. So it's flowing in there freely. Now, hydrogen, as you can see, has a positive charge. And the cell says, well, I can't have too many positive charges in here, but I have no control over where this hydrogen is flowing. However, with my sodium potassium pump, I can control sodium and potassium. So I'm going to kick out potassium. It chooses to kick out potassium. Where does that potassium end up? It ends up in the bloodstream. Therefore, in times of acidosis, what we may see is an increased serum potassium level. Now let's have the same conversation about alkalosis. And again, these diagrams here in the map basically outline exactly what I've just said. It just depends how you like to learn. I find diagrams helpful for this concept, but you can also use the maps. They say the same thing. So let's finish up here with alkalosis. So in a time of alkalosis, we have a relatively fewer hydrogen ions in the ECF. Fewer hydrogen, less acidity, relative to what's naturally in the cell. So what happens? Well, you know that these items, solutes, gases, like to flow from areas of high concentration to areas of low concentration. So naturally, the hydrogen starts to move itself out of the cell into the extracellular fluid. Again, the cell says, I'm losing my positive charge. What can I do? It typically chooses to pick up potassium by way of the sodium-potassium pump and bring it, draw it into the ICF. And that is why in times of alkalosis, we may see a drop in serum potassium levels.